All right, still in Chapter 6. We're going to be moving into Chapter 6, Section 4. But before we do that, I'm going to just quickly go over this as a reminder. We've done this year already, but as a little refresher, we'll talk about the complex numbers. Complex number, a number that can be expressed in the form a plus bi. So we're bringing I back. A and b are real numbers, and I is the imaginary unit. That satisfies the equation x squared equals -1. Okay, because what number squared equals a negative? There is none. So that's why we take out the negative and call it I. Okay, so some little math humor, some cartoons here. Square root of -1 is I heart math. Imaginary numbers are used in the real world. Engineers use them to describe electrical currents. And then here we have a cute little I is telling pi to be rational, right? Because pi is irrational, and then pi says back to I, get real. Okay. That's just to lighten the mood. For now, we will just simplify radicals that have negative radicands. Okay, so if I'm simplifying the square root of -2, we know this could be rewritten as the square root of -1 multiplied with a positive 2. We could use the product rule that says I can split these apart as such. And since the square root of -1 equals I put the I in front of the square root of 2. Okay. You could pause the video and do the next 3 examples of simplifying radicals. All right. Hopefully you did pause the video and try these on your own. Right? I could break this apart as -1 times 4. Show the product rule again. This is I. The square root of 4 is 2, so we get 2I. This one here, easy peasy lemon squeezy. The negative comes out as I. 81, square root of it is 9. This one here, 32 is not a square. So I did write it and broke it apart. Okay, -1 times 16 times 2, right? 16 times 2 is 32. The -1 comes out as an I. The 16, right? Square root of 16 is 4. The 2 has to stay in. So my final answer here is 4I times the square root of 2. Okay? And another little cartoon. 2 and 3 are speaking to each other. Hey, you guys want to meet my new friend? Well, look, 8 is saying, like, do you want to meet my new friend? And these two are, like, confused, like, what is going on? Sure, but where is he? He's right here. Why can't anyone else see you? Beats me. He's the square root of -1. He's imaginary. It's his imaginary friend. Ha, ha, ha. Okay, little corny joke. What are we going to do with this? Well, we're going to be solving polynomial equations. So, let's get to it. Recall the sum and difference of cubes. Remember I said factoring is not going away? Well, factoring is not going away. So if we have the sum of cubes, that would be like a cubed plus b cubed. And the difference of cubes is a cubed subtract b cubed. And remember when we factored these, take the cube root of each of those to get your a and your b. And it's always a binomial times a trinomial where the trinomial can never be factored. Some of you forgot that last time. This is, all right, so a times a squared would be a cubed. It's got to end with a b square. It's always plus, right? Because if you square positive or negative, it's always plus. And then the middle sign changes. That's why we don't have any middles here. And then it's just AB. Okay, and similarly, You still get your A and your B, but this time minus, right? That's minus, that's minus. But this looks very similar. That's A squared, that's AB, that's B squared. It has to be plus B squared. And this one, if that's minus, this is plus. Okay, so a little review on the formulas for factoring the sum and difference of cubes. All right, let's put in our steps. So for these problems coming up like these, example 1, 2, and 3, you always look to factor out a GCF if possible. It's not always possible, but if it is, it really helps. And plus, anyway, that's the first thing you're supposed to do with any factoring problem. Second thing, be sure that each term is a cube. Folks, if the number is 3, 3 is not a cube. 8 is a cube, right? The cube root of 8 is 2. 8 is a cube. So you have to make sure that if you are going to factor these in order to get solutions when we're solving polynomial equations, you have to make sure that they are cubes. So be sure each term is a cube. Use the formula to factor. And then factor completely. All right, so this, again, is just really a review of factoring sum and difference of cubes. Here I have sum, here I have difference, here I have sum. M to the power of 3 plus 8. Folks, if you look at m cubed is a cube. 8 is also a cube. Okay, so these are both cubes. There's a sum, an addition sign in between. So we use that first formula. How do you find your A? You take the cube root of it. That's m. Cube root of 8 is 2. Sign is the same here. Now we square the m. We change the sign. We multiply them together. And this one's always plus. And then you square the 2 and you get 4. And that's it. Remember, this can never be factored. Try as you may. Multiplies to 4, adds to 2. It's not going to happen. Signs are the same. Not going to happen. Never. All right, let's look at this. 27c to the power of 6 subtract 1. Well, you should recognize 27 as a cube. You should recognize that 1 is in any power, so it is a cube. Right? 1 is a square, 1 is a cube, 1 is a 4th power, 1 is a 20th power. Right? But c to the power of 6. Remember, an exponent is a cube if it is divisible by 3. Write this in your notes. An exponent is a cube if it is divisible by 3. Always. It's always a cube if it's divisible by 3. 6 is divisible by 3. So c to the power of 6 is a cube. All right. Equals. I'm going to set up binomial times a trinomial. It's always binomial times a trinomial. The cube root of this is 3, right? 3 times 3 is 9 times 3 is 27. Folks, take the exponent and divide it by 3. You get c squared. The cube root of 1 is 1. So right there is my a and my b. 3c c squared, subtract 1. Now you have to square this. This is a product raised to a power. 3 times 3 is 9. C squared times c squared is c to the power of 4. Now I'm going to multiply these two together and change the sign. It's plus 1 times this is simply 3c squared. And then when I square -1, I get a positive 1. So you're going to have to go back and learn how to work with these formulas again and learn how to find the first and second value, that A and that B. When I say A and B, I'm talking about these guys, right? How do you get an A cubed to be an A? You take the cube root. How do you get a B cubed to be a B? You take the cube root. We do the same thing here. And what's more is you have to remember that any exponent is a cube if it's divisible by 3. Okay, so why don't you pause the video and try example 3. All right, hopefully you paused the video. You should have seen that 6 was not a cube, right? There is no number when you multiply it by itself 3 times. That's going to give me a 6. So it's not a cube. You should have seen a GCF, okay? GCF. GCF is 6. I could take a 6 out of here and here. And when I take that out, I end up with this expression inside the binomial. Look at the exponents. 12 and 15 are both cubes because 12 and 15 are both divisible by 3. The GCF part has to ride along. It's part of the final answer. Take the cube root of x to the 12th, which really means take this and divide it by 3, and you get x to the 4th, plus y to the 15 over 3, or y to the 5th. To get these terms, this is an 8, by the way, you do x to the 4th. This is x to the 4th times x to the 4th. Remember, when the bases are the same, you add the exponents. That's why that's x to the 8th. This is y to the 5th times y to the 5th, right? You have to square this, which means multiply it by itself. Base is the same, add the exponents, so you get the y to the 10th. And then we just move these next to each other, x to the 4th, y to the 5th, and change the sign. Okay, so if you have questions on that, please ask. You know, I can't help you unless you have a question for me. Okay, on to the next page. What do we have? What do we have? This here now says solve the following equations. And notice I do have cubes. All right. This I'm going to kind of puzzle to give myself some good workspace. So I separate my problems. So I guess I will use red. All right, x cubed plus 1. I can factor the left side. So let's do that. Factor. All right. That's why we did the mini lesson on factoring. Cube root of x cubed is x. Cube root of 1 is 1. Sign is plus. Square this, x squared. Minus x plus 1. Now I know what you'll be tempted to do. You will be tempted to take the 1 over to the other side and then take the cube root. While that is a viable method, you lose sight of your imaginary solutions. And so please don't do that, because I'm going to want to see the imaginary roots. All right, so we did the factoring. Now we have to use ZPP. All right, so I get x plus 1 equals 0, or x squared minus x plus 1 equals 0. Here x equals -1. Try as you may to factor this. Multiplies to 1, adds to negative 1. It's not going to happen. It's not going to happen. You can't factor this. That doesn't mean you're done. That means complete the square or use the quadratic formula. I like complete the square. So write complete the square or QF, quadratic formula. All right, remember the leading coefficient of the x squared term has to be a 1 to complete the square. I got x squared minus x. You move the constant term to the other side, negative 1. Now I'm going to set up for some square to add to both sides. Remember doing this? All right, half of 1 is a half, and when you square half, you get a quarter. So what goes in my little box here is I'm going to add 1/4 to both sides. Remember, what we're learning here right now is not new. The only thing that's new is how to solve a cube equation. Complete the square is not new. I got a single binomial squared, x minus, right, square root of a quarter is a half, equals, this is negative 1 plus a quarter. Well, negative 1 is really negative 4/4. Plus a quarter is negative 3/4. Take the square root of both sides, x minus a half, equals, plus or minus, square root of negative 3/4. X equals, I'm going to take the half over, always goes in the front, plus or minus. I'm going to take the I out, it stays in the top, root 3 over root 4, but root 4 is 2. Okay, so I have two imaginary roots here. I've got x equals 1/2 plus I root 3 over 2, and x equals 1/2 subtract I root 3 over 2. Remember, you have to write them as separate answers. So I've got one real solution, negative 1, and I've got two imaginary roots or solutions. Okay, so if you have questions, please ask. If you're stuck on complete the square, then it would probably behoove you to go back and watch that video lesson again or get out your notes to help you. Okay, the problem right next door. I see the x cube, and I'm like, that's a cube, but 3 is not a cube. But remember, you always should first look for a GCF. There is a GCF in this problem. GCF is 3. So I'm going to factor out a 3. I get x cubed. 3 does divide 81 27 times. And now I have the difference of cubes, which is going to factor as x minus, right, cube root of x cubed is x. Cube root of 27 is 3. So this is x minus 3. Square this, x squared. Add 3x. Plus 9. Three will never be a 0. That's a stretch. Remember when we did these graphing? Okay, so 3 is never a 0. Remember, this thing can never be factored. Never. It can never be factored. So you are going to be doing complete the square or quadratic formula. The a is 1, so I'm just going to complete the square. Okay, so for this part here, x squared plus 3x plus some square equals negative 9 plus that same square. And what is the square? Well, half of 3 is 3 halves. 3 halves squared is 9 over 4, if you remember that. Right? Remember we said don't let taking half of an odd number scare you. It's just 3 over 2. And don't let squaring that scare you. You just square the top and you square the bottom. All right, this, pretty easy to factor. Oops, not x squared, x to the power of 1. My brain is thinking faster than I'm writing. Okay, so this is x to the power 1 plus square root of that is 3/2. And that's quantity squared. Now remember, I need a common denominator. 9 times 4 is 36. So this is negative 36 fourths. Negative 36 fourths plus 9 fourths is negative 27 fourths. Okay, so again, remember you had to get a common denominator. This negative 9 is negative 36 over 4, right? 36 divided by 4 is 9. So negative 36 fourths plus 9 fourths is negative 27 fourths. Okay, I'm going to square root both sides. X plus 3 over 2 equals plus or minus. You can take the I out right away. You know it's going to be I. Root 27 over root 4. Root 4 is 2. Now I'm going to take this negative 3/2 over. It becomes negative. Plus or minus. 27 is not a square, but it does have a square factor, 3. So this is 3I root 3. Right? 27 is 9 times 3, so the 9 comes out as a 3. And root 4 is 2. All right, now I can write this as 2 imaginary solutions. X equals negative 3 over 2 plus 3I root 3 over 2. And x equals negative 3 over 2. I had addition there, and this one has to be subtraction. 3I root 3 over 2. And I do have one real solution. ZPP says x equals 3. This will never equal 0. Will never equal 0. Okay? The 3 is coming from that factor. Okay, so it might get you a little bit, it might take you a little bit of time to get back into the groove of completing the square. But it is not undoable. Oh, the next problem. Notice, this is x to the power of 4 plus 2x squared minus 1. This is a different type of quadratic. It is quadratic in form. So let's go with green on this one. This is a different type of quadratic. And why am I saying it's a different type of quadratic? Well, x to any even power is quadratic. It is divisible by 2. Well, it's a square anyway. Right? If any exponent that's divisible by 3 is a cube, then any even exponent is a square. So this is an equation that is quadratic in form. It's not quadratic because we know the quadratics are x to the power of 2. But it can still be factored as such. In other words, I can just pretend that this is a 2. And I'm going to factor it the same way. In other words, I'm going to say multiplies to 24, look at the A is 1. Okay, the leader is 1. Multiplies to 24, subtracts to 2. That's 6 and 4. The only thing is here, this can't be x and x, because x times x is x squared, not x to the 4th. But if I make them both be x squared, then that is x to the power of 4. And now if I check it, x squared times x squared is x to the 4th. This is 6x squared, 4x squared. Notice I have an x squared term in the middle, so this is going to work. Signs are different, larger product is plus. Folks, when we're talking about the larger product, it's the product of the outers and the inners. Which one's bigger? 6x squared is bigger. That gets the plus, that gets the minus. Now I can take my two factors. X squared minus 4 equals 0, and x squared plus 6 equals 0. Use ZPP. X squared equals 4. X squared equals negative 6. Take the square root. X equals positive. Remember, when you square root, it's also always positive negative. X squared equals positive negative square root of negative 6. The negative's inside the radical. All right. I'm going to simplify this because root 4 is 2. So x equals positive negative 2. This, I'm going to simplify by taking out the I. X equals plus or minus I. 6 can't be simplified. If it could, then I would, but it can't, so I won't. My solutions are x equals negative 2, positive 2, negative I root 6, and positive I root 6. Okay, so just remember, when you see a fourth power here and a second power there, this is just a different type of quadratic. They factor the same. So now that you know that, why don't you pause the video and try the last problem? All right, hopefully you paused the video and worked out this problem on your own. It's x to the fourth power, that's x squared in there. Try to factor it as a regular quadratic trinomial, and it does factor. Multiplies to 56, adds to 15, that's 7 times 8. Signs are the same, they're both minus. Use our ZPP. All right, x squared minus 7 equals 0, or x squared minus 8 equals 0. Solving, add 7. Take the square root. X is equal to positive or negative root 7. Same thing here, add 8. Take the square root. X is equal to positive or negative square root of 8. Here, you must simplify the radical. We've done this as well in our radicals lessons. Okay, so if you are rusty on that, go back, take a look at that again. And here I have 4 real solutions. This time x is equal to negative root 7, positive root 7, negative 2 root 2, and positive 2 root 2. Okay, you have any questions? Please post on that homework discussion and or ask questions in class. And that's about all I have for you. If you're struggling on the homework assignment, you know what to do. Get in touch. Thank you. Have a great day.